After a few years working on Scheme full-time, I finally realized that you can use macro not only in the first element of S expression, but in arbitrary position. And that leads to a lot of possibility of macro usage. And the 5th chapter of Fear of Macros book led me to this exploration. And today I will share some thoughts on what we can do and how we can do something interesting with this information. I'm under Tropin. I work on operating systems and programming languages and do a lot of free and open source software along the way. So let's get started with a very simple example. I can define a simple variable which contains some value, and after that I will define a very simple macro which called hey alias, and it basically does a very simple thing. I will comment out everything that is unrelated to this macro at the moment, like this. It takes a syntax object and tries to destructure it. The structure is very simple. It takes the first syntax object and checks if it is an identifier, and if it is, it substitutes the syntax object with a new one called hey. What does it mean? That means that we can access through the hey alias macro the value of hey variable. And for example, we can call a function with a hey alias as an argument, and you will see here it prints the value of hey variable. And you can expect that we can also use this hey alias as argument to set the value of this variable, but it's not the case because to make set work with this macro should be marked as variable transformer, and for our implementation it's not the case. But the solution is very simple. We just need to wrap our lambda, which represents our transformer, into make variable transformer call. And make variable transformer call is very simple procedure. It checks if the argument is procedure, and it adds the meta information to the procedure. And it adds actually two fields. First one is macro type, which is set to variable transformer, and the second one is variable transformer key set to true. Let's see how it looks. If we take the value of the make variable transformer call, let's actually make it a bit more verbose. Define tmpfn. We will just assign to tmpfn the value, and now we can call procedure properties of tmpfn like this. You can see the only procedure property here is name, which is equal to tmpfn. But when we wrap this lambda into make variable transformer call, something changes. We can see two more additional fields appear here. Variable transformer equal to true and macro type equal to variable transformer. Why we need both? I don't know. It's probably the details of implementation of macro expander. I think we could live with only one of those, but I think it's not a big deal. We can explore it someday later, maybe when we will be implementing our own macro expander. Okay, so we can define syntax of hey alias like this, and now we can use it not only to reference the value of hey variable, but also to use a set procedure with it. And now if we access the value, you can see it changed. And even if we access the value of hey variable, it also changed. And it happens because our syntax transformer is marked as a variable transformer, and it also contains a syntax case which matches against set var value, and it substitutes it to this thing. Actually, the funny part here that the set here is not matched literally, because we didn't specify set here, but we actually should specify it here, I guess. That means that this pattern can match against something that we don't expect to be matched against. Let's define a function. Define second, which takes two arguments, lambda x, y, and returns y, for example. Or let's call it first. Now, if we call a first on hey, alias, and ho, here, okay, it works. It works, and it didn't match against this case, the syntax case. And why it happens? Why it happens, I don't know. Probably because of the way macro expander works. Because macro expander probably treat variable transformer only if the expression starts with set. Otherwise, let's do the following. Let's just print display x. Can we do it? I think yes. Pam pam. And let's call it again. Ho. Where our display? Oh. We need to redefine this one. Yes. Okay. You can see that in this case, the syntax we got into our syntax transformer contains only one element, the identifier hey alias. That means it doesn't know. It knows nothing about the context. But when we call the set, you can see in this case we have an expression which contains set hey alias and quoted ho here. Yep. And now we verified that this pattern will match only against set, because set is treated in a special way by our macro expander. Is it good or not? I don't know. It would be cool if macro expander can provide the context of the expression to this macro, but it raises another question that we probably can't answer. How much of the context we need to provide to this macro in this case? Do we need to provide the nearby expressions which contain it in one expression, or we need to provide it up to infinite level? Another call here and another argument here. Do we need to provide the whole enclosing expression to this macro or not? That's probably we only provide this syntax object to the macro when it used in the position in the middle of the expression, and we provide a bit more verbose syntax object when it used with set, which is a special case. But if we use hey alias here, you can see it will throw the exception, which is obvious. But let's assign it a function, like this, and now we can call it with 2 arguments. Whoa. I think I got the infinite loop somewhere. Because you can see it printed a lot of stuff. It printed so much stuff that it's lagging when I scroll it. And this is an interesting question why it happens. Make variable transformer. Can we quote it like this? No, didn't help. It returned a syntax object which contains hey, and hey actually is a function, and it should call hey alias, and it should work fine. Why it goes into infinite loop? Let's see. Let's call it one more time. No, it still spends a lot of time. Let's do a bit more manageable output with new line, so we can see define syntax. We can see the argument that it accepts on a separate line. Okay, it gets a list. It gets a syntax object which contains a list, which contains hey alias, hey, oh, I see what is happening. I see what is happening and why it goes into infinite loop. This happens because it's interesting. It should actually throw an exception because I don't think that the list is considered as identifier. Let's check it. Let's display identifier of x. Is it identifier? False. It's not identifier. And when I destructure x, I just put its value into var, and I check if var is identifier, and it should not match this guard should return false, and the syntax case should return an error. A syntax violation. But let's try do the following. Pam hey alias, like hey alias, or just underscore instead of its name. After that, argument 1, argument 2, and the call, a syntax object, the call to hey function, like this, hey a1 and a2, like this, and let's do it. And now it works. This is how it should work. But what happens when we have this pattern which matches against the whole expression? So this pattern definitely matches. It should, because you know it can't avoid matching, because it's basically a wild card. But this guard should fail. Let's read the documentation of syntax case. Pam 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 pam. Syntax form. Pam pam. Syntax keyword pattern template dummy pattern template by syntax key. Okay, this one, underscore var identifier. What if now the quoting of hey won't help? Oh, I see what is happening. I finally realized what is happening. When we are in this place and try to evaluate this expression, and we are at macro expansion phase, the first argument is basically a macro in arbitrary position of expression, and we try to expand it. We expand it to hey. And that means that we basically should get hey here, like this. Okay, maybe I still didn't understand it. It's definitely not happening, because we can see in the output here that we get a syntax object which actually okay, now I understood. What is happening here. We match against the whole expression, because it's in the position at the beginning of S expression, it doesn't expand the way it expands in the middle of S expression, so, like this, for example. And it tries to expand the macro with the whole expression context. And we have a syntax object which contains a list of other syntax objects, right? We match against this list of syntax objects, like X is our list, we already printed and checked that it's not identifier. And we destructure it and get this just a list of syntax object, and we try to check if it is an identifier. And here, when we put it back, it probably tries to expand the macro again. This is my expectation. Let's put it like this. Define syntax. What? Now I don't understand why it works. Okay, let's try to remove this syntax case. Okay, now it fails. This is really interesting. What if we change those expressions? If we add this case, it starts to work, and even if we add it later, it still works. This is mind-blowing. Okay. I got it. You know, do you remember I mentioned that we need to specify set here to match exactly the only set case? This is where it became useful finally. Okay, I found the issue and why we get into infinite recursion here. This is very simple, because if we change the set to underscore, nothing will change. I mean, when the set is not specified here. Oh, I'm sorry. If we do like this, yep, you can see The pattern which we have here contains 3 elements, and this call to macro also contains 3 elements. And when the first element is matched against hey alias, what we basically do, we transform our expression into another expression where the first element is hey alias again, and it tries to macro expand it one more time, and the process repeats infinite times. That is why we got infinite recursion. What happens when we put set here? The same, absolutely the same thing happens, because it gets expanded into the same hey alias, and it will try expand it infinite times. When we put set here, we make this pattern match in a slightly different way. It will match not with arbitrary value here, but only if the value here is actually set. So it will match only this case, but not this case. And that means it won't create infinite expand recursion. And now, if I evaluate this macro and I will try to run it, I will get an exception that we actually expected earlier to get. And here, if I want to make it work, I will need to add this pattern that I had before. Oops. Wrong type to apply to A1, A2. Now I'm puzzled. We have argument 1, argument 2, A1, A2, and call to the hey, right? And our hey is a procedure, is the first procedure. Okay, probably we somehow updated the definition of hey value. Yep, now it works. Boom, boom. Great. And we comment this pattern. And we get the exception, because there is no pattern for matching this call anymore, because we specified set here, and now it matches exactly like if I write it like this in our usual ICE9 match. Great. We faced a few interesting issues and figured out them, and it's very good for learning because it makes much more neural connections, and it makes you remember the material much better. Okay, let's go to our syntax parameters, which is actually the topic of chapter 5 that we tried to cover on previous stream, but didn't finish because we didn't have syntax ID rules which needed for implementation. But now we have a more knowledge about macro system of scheme language, and we know alternatives to syntax ID rules. And this alternative is identifier syntax. And if you take a look at identifier syntax implementation, it's just a very simple macro which returns a macro transformer. So that thing basically takes some syntax, match against it, and returns a syntax transformer, another function which accepts a syntax and returns the expression. And you can see that there are two cases. The first case, we can use identifier syntax, just takes one argument, the expression, or usually the variable, but it can be the arbitrary expression. And here you can see how it works. Let me think a bit. Yeah, it takes arbitrary expression. It can be whatever you want. Let's check it. Identifier syntax plus 1 2, like this. It returns a function, and if I take a very simple expression, let's make it okay. Whatever we have arbitrary expression plus 1 2 3. No, it's like hard to read. A b. We have a function a which accepts one argument b, and you can see that the result will be the following. Instead of first argument a, we get an expression plus 1 2. So that means that basically our identifier syntax will provide the following result: plus 1 2 b. That what transformation will happen after you used identifier syntax in this way. You provided arbitrary expression, you get this transformation. But there's also another way to use it. You can have identifier expression and another rule which contains set, variable, value, and expression too. That means that you can use identifier syntax in a way I never used it. So it is the first time I actually do it. It will contain identifier. Let's see E1, expression. Whoa, something is falling out of the tree. Plus 1 2. Okay, and now we need to provide a set, variable value, can we use where VL here and here for the expression? We will do like this. It doesn't make sense to use it this way, but it can demonstrate how the macro work. Define identifier syntax transformer, EST, like this. So it's easier to use. Now we need a syntax where we have something like plus I1 4 5. Okay, and we see how it expands. it get expanded, but not the way I expected it. Not exactly the way I expected it to expand. Let's see the implementation one more time. ID. When we have ID x. Oh, okay. It will work only if I is in the position here. I5. Like this. Alright? But if we have it here, it expanded, but the I1 still here. So we can't use just I1. Or we can. Let's see. We definitely go into this case, syntax case x set. Okay, if we have ID just as ID, we change it to expression 1. Yeah, it should work in arbitrary position, like list 5i1 should not produce this result. Should not. It must not do this thing. Identifier syntax. Let me check. I saw the implementation here, and identifier syntax ID x expression x. Oh. Okay, okay. Probably I got what is wrong here. Let's define syntax est, right? And after I use est like this, it returns 3. Or if I macro expand, it returns this expression. If I do it like this, okay, so it actually worked. I just misused it a bit. So it basically ignores the ID or not. What if I do like this? I don't understand. The only item here is this ID expression. It doesn't affect anyhow the further expansion. whatever we place here, it just ignored. If you do it like this, it gets expanded to this expression. Okay, let's do one more thing. Let's set east to 5, right? Let's try to do it, and let's try to expand it. And you can see, let's, for the sake of more visibility, modify our syntax. You can see when we do set ist5, it expands according to this rule. And we can even swap those to get it clearer. Okay, you see, this one matches very good. If we use first, it expanded to this one, and it will return 3, of course. But if we use set, it expanded to this expression. The only problem here that I have with this macro, why we have ID here and why we have ID here. Are those IDs anyhow related? Probably no. Or yes. Yes, no. No, yes. It checks if ID is identifier, it checks if var is identifier, and it returns a syntax object which calls make variable transformer blah blah blah, and we actually don't need this line. It will be already added by make variable transformer, so this is unnecessary. I need to write a to-do. Send patch removing unnecessary meta information from identifier syntax. Okay, let's skip it for now. We'll figure it out later when we have a bit fresher mind. I got it. I guess I got it. This ID is actually ignored because the syntax case will bind a fresh ID to it, and this one only needed to check if it is identifier. But for what actual heck we need it to be an identifier? It never used later on. Oh, maybe we can use it in the expression too. Do we? Can we? Probably no. Let's try. Sorry, I'm just curious about all that stuff. I'm just curious about all that stuff. No. Absolutely no. Okay, whatever. It seems it's just a syntax. Oh, okay, it can be used here, maybe. Let's see. Yeah, it can be used to create infinite recursion. I broke everything. Okay, let's restart the REPL. Let's quote it, but I don't think it will help. Oh, okay, it helped, and we were able to use its value inside the expression. So we found the usage for this to be bound to something. Very cool, very nice. Sorry, I got curious again. I want to define an alias. Define syntax is alias which accepts x syntax case x, and how it works. Like this is alias, and now what if I put ist alias here? Boom. Oh, my bad. Again, I messed it up. Why interruption takes so much time? Probably it won't interrupt because I got a deadlock here. Maybe not, but whatever. We'll figure it out later. Let's eval this one, and expand this one. Okay, it get expanded to ist, which is kinda expected, right? Yes, it's relatively expected. Okay, now let's get back to the topic and actually to syntax parameters. We understood that we can use macro not only in the first position of the expression but in arbitrary position of the expression. We have identifier syntax helper, which allows to define such macros in a bit easier way than we defined here. But basically what we do with identifier syntax is equivalent to make a variable transformer ourselves. And let's see the implementation of aif. I will remind you that aif is a version of if where we take the expression that we are checking against, and now we can reference this expression later using the variable name. And to define it, we will need a syntax parameter, which is the same as usual parameter, but for syntaxes, for syntax transformers. And I already had a stream on fluids, dynamically scoped variables and parameters as one of the implementation of dynamically scoped variables. And you can watch it somewhere here or on my channel. You will figure it out, I'm sure. Now let's define our syntax transformer called aif. We will define it using syntax rules as it defined here. It takes a few arguments: the name of the macro, the expression to test, then clause and else clause, which are all expressions. Now we set the value of test expression to variable t, and after that we call syntax parameterize and set value of it, which is by default a syntax rules which match against nothing and always throw a syntax violation. If you use it like this, we got exception. If we use it like this, we got exception. If we use it like this, we also got an exception, because syntax rule don't have any patterns that matches. We can be more specific and create a default clause that says, I don't know what it says. For example, it says syntax violation, syntax error. Syntax error, it can't be used outside of aif. Great. Syntax error. Okay, am I using syntax rules incorrectly? Where we have syntax rules? Syntax rules, expression. Okay, it straight goes for expression, I guess. Like this. I forgot how to use syntax rules. Do we have other examples? Okay. Let's do it like this. Nice. And if we use it, now we get a message. Source expression matched to. How to make syntax rules match against any case? Okay, whatever. I don't like syntax rules. I will use syntax case, a lambda x, because syntax case, in my opinion, is more mature option. Syntax rules. And it should return message invalid literals. syntax case. Oh, okay, my bad. Do we always have to return a syntax object? A region message, it can be used. Now it works as expected. If we use it outside of if, it returns an exception. Nice, great. Even if we use it here, it will throw an error expansion time, which is great. Very much like it. Now to the implementation of a if. We have syntax parameterize where we set the value of it to identifier syntax. And this identifier syntax, the function we extensively discussed earlier, just takes the expression and changes to t. And t in our case is bound to test. And now you can see the usage of a if. We have the expression. Its expression evaluates to 7, and 7 is treated as true. And later in true branch of if, we reference this expression as it variable, and it gets substituted with 7, and you can see the 7 is printed. Voila, works very much as expected, which is cool. Now let's try to rewrite a if to syntax case. It will be lambda x syntax case x blah 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 a if test, and now we need to return a syntax object like this. Will it work? Not sure, but it works. It works. Okay, we'll see what it expands to. It expands to very simple let. By the way, if void is unbound variable, which is cool. That means that this part never get evaluated, so it never fails, which is very nice. What else? If for some reason we already have our t bound to 1 to 3, right? And we use the t. Oh, let's not use it. And let's see to what it expands. T 1 2 3, T 3 4. You see that inside the scope of this let, inside the scope of if, the t variable right now bound 2 times. First time here and second time here, and the final value 7 is used. But if we use it in this expression, and let's try to evaluate it one more time. Let's see what is going on. We see it is expanded. But it expanded in a very strange way. The result, however, is right. But the macro expansion looks a bit strange to me. Okay, we see the t variable is used in the expression and shadow it, but nothing bad happens because we have let asterisk, which allows to reference the previous expression here. So hygiene is not broken here, and we don't have any problems here. But let's make it more complicated. Let's display the value of variable t, new line, and display the value of the expression. Now let's see if it works. It returns 123 and 130, which are correct answers. That means that our macro expansion also worked correctly, and now you can see that the first variable t is renamed to t1, and the second variable t is still the same. Actually, I would expect to t be renamed, but for some reason the t1 got renamed, which is very funny, very curious how it happens. But we'll figure it out when we will be writing our own macro expansion. So let's get back to the topic of our lesson. It's identifier syntaxes, syntax parameters, and variable transformers, and we covered all of them. So, small recap for today's lesson. We found out that the macro can be used in arbitrary position in the expression and not only in the first position of the expression. If it used in arbitrary position, we can match it like this. Also, we have a special case for set, and we can match against this case like this to make it possible to use this macro as argument to set and like change the value it references. Also, we learned that only variable transformers treated in a special way that make this pattern against set work correctly. And also we found out why those parentheses to syntax case are actually useful. They allow us to specify identifiers that we need to match against explicitly, like it should match like exactly, not explicitly, exactly, and it will prevent our infinite recursion that we got today. So it's a macro transformers, variable transformers. And identifier syntax is just a simple macro which sometimes simplifies the writing of such syntax transformers, and it accepts two forms. First form just accepts one expression, and it changes the first argument of the expression to the expression specified to identifier syntax. Also, it can accept two arguments. First one will be the identifier and the variable, the expression we will use instead of the the expression that we will use instead of the macro when it used as identifier, and another case which will match against set and the expression that we will use instead of calling a set. but we can of course call set here. What else? The syntax parameters, just usual parameters, and we demonstrated how we can define them and how we can set them for some small scope, and after we get out of the scope, the value of syntax parameter returned back to its original value. So that's basically it for today. Oh, there's a question. What are you using? Is Emacs? Yes, I'm using Emacs. Moreover, I'm using a distribution of Emacs called RDE Emacs. The distribution I created some time ago, like from the scratch, and it's inspired by DOM Emacs, Space Emacs a bit, but it's very vanilla flavored, so there is no like too much fancy customization. It's like as close to vanilla Emacs as possible. And on top of Emacs, I use Arei's ID that also was developed some time ago, I guess a year ago, and it's still in active development. And it's probably the best ID for working with Guile scheme at the moment. So I guess on this beautiful note, we can finish our stream. Thank you very much for joining me, and I hope you enjoyed it, and I will see you in a bit. Bye.